Here is a problem of partial fraction decomposition. Let's look at it. We have x all over x plus 1 times the quantity x squared plus 9. Here's our goal. We want to end up with two fractions. One fraction that looks like a all over x plus 1, and a is to be determined later, plus bx plus c all over our second factor, x squared plus 9. So we're going to try and break this up into two fractions in essence. The way we'll do this is multiply both sides of the equation by our denominator on the left-hand side, which is x plus 1 times x squared plus 9. And as always, what we do to one side, we have to do to the other. So we're going to multiply the right-hand side by x plus 1 times x squared plus 9. And watch what happens here. By design, the x plus 1s will cancel out on the left. As well, the x squareds plus 9s will also cancel, leaving us with simply x. On the right, it gets a little bit dicey here. The x plus 1s will cancel out, leaving us with a times x squared plus 9. Don't forget to take it times the second fraction. Here, the x squareds plus 9s will cancel out, leaving us with a little bit of a mess here. Bx plus c times x plus 1. And now we have to simplify. Distribute our a through to get ax squared plus 9a. Foil this problem out. We're going to come up with a bx squared plus a bx plus a cx plus a c. Okay, now let's gather all our like terms on one side and see what we have here. I'm going to leave the x, believe it or not, on the left, but in terms of the x squared, we have ax squared plus a bx squared. I'll mark those. Let's look at our x terms now. We have a plus bx plus cx term here. And finally our constants, plus 9a plus c. And the reason I want to leave this x on here is so we have a frame of reference. Note that on the left we have no x squared terms. So what that will give us is the equation a plus b has to be equal to 0 because we have no x squared term on the left. Next, looking at the x terms, we have bx plus c. We need a coefficient of 1, so we can come to the conclusion that b plus c has to equal a positive 1. And then finally, because once again on the left there is no constant, we're going to come up with the equation 9a plus c is also equal to 0. Now that we have our three equations, let's go ahead and solve. We have a plus b is equal to 0, b plus c is equal to 1, 9a plus c is equal to 0. I want to start right here. A is equal to a negative b, and go ahead and plug that into our third equation to obtain negative 9b plus c equals 0. And now what we have are two equations in terms of b and c. Our new one here and our old one, b plus c equals 1. Let's go ahead and line those up here. Minus 9b plus c equaling 0. So we can solve that system using either the addition method or the substitution method. Let's go ahead and substitute. I'm going to solve for c in the first one. C is equal to 1 minus b. We can plug that into our second equation. From this we'll get a minus 9b plus 1 minus b equaling 0. And if we solve this carefully, we come up with a value of b is equal to a positive 1/10. And that is part of our solution. Okay. Now our goal is to come up with a and c, and this will finish out the problem. So plug b back into our first equation. We know that if we put in a b here, we can find that a is equal to a negative 1/10. So that's another part of our solution. And finally, we need to come up with c, and I would plug b being equal to 1/10 into our second equation. So we have 1/10 plus c is equal to 1, and from this we have c equaling 9/10. Now it seems like forever, but if we go back to our original problem, remember what we were looking at. We had a over x plus 1 plus bx plus c. Now a we found to be a negative 1/10, so we substitute that in here. B we found to be a positive 1/10, and that's our coefficient on the x term. And C, our constant, was 9/10. So we've taken our original single fraction and broken it into two fractions, and this is a nice example of partial fraction decomposition.